Today's lesson, we're looking at the 4 operations with algebraic fractions. So algebraic fractions are fractions where one of the terms or 2 of them will have pronumerals in them. Now the rules for adding and subtracting algebraic fractions are the same as the rules for adding and subtracting ordinary fractions, that rule being that the denominators must be the same. Okay, so when adding or subtracting algebraic fractions, first convert them so that they have the same denominators. Now let's look at these first few questions, questions 1, 2 and 3. Okay, let's look at question 1, h over 5 plus 3h over 5. Are those denominators the same? Yes, so we just add the numerators. So it'll be 4h over 5. The second one here, obviously the first row is going to be fairly easy. Are the denominators the same? So just subtract the numerators. What have we got? 3h. Can you simplify 3h over 9? Great. We divide both the numerator and the denominator by 3. Excellent. We're moving over to the third question. Question 3, denominators are already the same. So what do? Add the numerators. What have we got? 10h over 3 cannot be simplified. And the last one, what denominator are you going to make both those fractions? 8. So what do we need to do to the first fraction? Multiply by 2 over 2. So what do we end up with? 2h over 8 plus h over 8. Are we okay with that? Which is 3h over 8. So in question 4, we're multiplying the numerator and the denominator of the first fraction only. It's our smallest common denominator. Ladies? No? Yeah, so we're going to multiply the first fraction by 3 over 3. And we're going to multiply the section, sorry, no we're not. We're going to multiply the first fraction by 4 over 4. And we're going to multiply the second fraction by 3 over 3. You can just do it there in the question. I know what I've done is quite messy. So what have we got? We're multiplying the first fraction by 4 over 4, the second one by 3 over 3. So we've got 28d over 12, take away 9d over 12. 28 take away 9 is, sorry about that mess, 19d over 12. Now that can't be simplified. No number goes into both 12 and 19. So do you want to just try some of the others? Just be careful with question 8 that you don't make your denominator too big. Go always for the smallest. What are we going to do with question 6? Just multiply the first fraction by 4 over 4. 4d over 8 minus 3d over 8. What does that equal? Yeah, 1d or just d over 8, and you can keep working. Fraction by 5 over 5, and multiplying the second fraction by 3 over 3. You can just do it there on the question if you want. We've got 10d over 15 minus 3d over 15. It's plus actually, which is 13d over 15. Now with the last one, who made common denominator 40 and who made common denominator something else? Yeah. Girls, I wouldn't go common denominator 40 because both those numbers, 4 and 10, go into 20. So if you do 4 times 10 is 40, always halve it. 20, do they both go into 20? Yes, then 20 is the lowest common denominator. So what you're really supposed to do is the biggest number, you do the multiples of the biggest number, like you count up 10, 20, etc. And because 4 goes into 20, then 20 is the lowest common denominator. But you can make it 40. But if you do, you'll have to simplify. So if you went 40, you would have got 14d over 40, which is 7d over 20, as long as you simplify it. So I'm going to go common denominator 20. So times 5 times 5, and times 2 times 2. And we get 5d over 20 plus 2d over 20 is 7d over 20. However, if you went common denominator 40, you would have had, see, you've got to decide what your lowest common denominator is, and I've decided it's going to be 20. I know that 4 and 10 both go into 20, but you could have done 40. But if you do 40, you would have had 14d over 40. Then you had to divide the numerator and the denominator both by 2, because you must have simplest form as your answer. Denominator of this one is 2x. All I need to do to the other x to make it into a 2x is to multiply it by 2. So with this one, I'm just going to times the second fraction by 2 over 2. Okay? So I've got 3 over 2x minus, what do I have, ladies? Minus what? Minus 2 over, what's x times 2? 2x. Now that my denominators are the same, I just write out my denominator and keep it the same. And I subtract my numerators, which is 1. Okay? So for algebraic fractions, so just think, what do I have to do to the x to get 2x? It's multiply it by 2, not by x, all right? Because x times x is x squared, but x times 2 is 2x. All right, this one, common denominator. What common denominator? We're going to go for 10 as our common denominator with the next one. So we're going common denominator 10. What do we have? Come on. 8x over 10, take away 5y over 10. Now, ladies, 8x take away 5y, they are not like terms. You can't go adding and subtracting x's and y's. You just leave it like one fraction. 8x take away 5y over 10. Okay with that? So you can't, in all the other cases, we've been able to add and subtract or subtract the numerator. But in this case, we cannot. 4 can easily be converted into the 8. So we'll just multiply our second fraction by 2 over 2. So we've got 7x over 8, take away what? Take away 6y over 8. Denominators are the same, however the numerators cannot be added or subtracted. So you just write it as 7x take away 6y all over 8. And the last one, just be careful, there's an x that's in common, that's good. But it's just like making the 3 and the 2. Just pretend you got the 3 and the 2 on the denominators. Because the x's are the same. So what do you think you multiply the first fraction by? If it was just a third over 5 over 2, what would you multiply by? Pretend the x's aren't there. What would you do to make them the same? You would times the first one, no, by 2. And you would multiply the second fraction by 3. Now, the reason you just have to worry about the numbers is at the x's, you've got the same powers of x there. It's not the x's that are the problem. It's the numbers that are the problem. So 1 times 2 is 2 over 3x times 2 is 6x plus 5 times 3 is 15. That is also over 6x. Now we've got a common denominator. 15 plus 2 is 17. Multiplying and dividing fractions. Now when multiplying fractions, you must always check if you can cancel out anything, any common factors between the numerator and the denominator. And when that's done, we just multiply the numerators and multiply the denominators. But before multiplying, we should always cancel. Otherwise, we could end up with some very large numbers. Okay? But you do have a calculator. So you could, if you want, just multiply and then put the fraction in on your calculator and it'll simplify it for you. So, however, when dividing by a fraction, it says we multiply by the reciprocal. Do you know what that means? You change the divide to a times and then you flip. All right, now what I'm going to do is I'm going to write the rule for dividing here. So, actually I'll write both rules out. So when multiplying, for example, a over b times c over d, if you're multiplying those two fractions, it'll just be a times c over b times d. Are you okay with that? So when multiplying fractions, you just multiply the numerators, multiply the denominators. However, when you divide fractions, a over b divided by c over d, we don't just do a divided by c and b divided by c. We keep the first one the same. We change the second one, change the divide to a times, and we flip the second fraction. KCF, not KFC. Keep, change, flip, KCF. Keep the first, when dividing, keep the first fraction the same, change the divide to a times, and flip the second fraction. Why do we do that? Because the inverse operation, or the opposite of dividing, is timesing, and the inverse of C over D is D over C. So two inverses cancel each other out. All right? So that's what we do when you're dividing two fractions. Keep the first one the same. We get to the divide and we say, I don't know how to divide, I only know how to multiply. So I change the divide to a times, and then I flip what comes after it. Okay, let's start. Always, before we start, we need to check if we can cancel. The first question, any cancelling or no? I just look diagonally, nothing goes into anything. What's h times h? H squared over 3 times 4 is 12. Now the second one, is there any cancelling that you can do? There is. Look at the 2 and the 8. Or do you prefer just to multiply, ladies? All right, if you want, we can just multiply. What do you get if you multiply? 2dh alphabetically over 8 times 5 is 40. However, if you do it this way, you must realise that 2 over 40 can be simplified because they're both even. You divide the 2 and the 40 both by 2, or on your calculator, you just go 2 ABC 40 equals, and it will give you 1 over 20. So what you're doing here is now dividing the numerator and the denominator both by 2. If you're not going to cancel out before you multiply your fractions, you're going to have to simplify at the end. All right, now they don't care how you do it as long as you do it. So you can't give the answer as 2dh over 40. It must be dh over 20. All right, ladies, the next one. Can you see how we cancel or no? For those that want to cancel, do you want me to do it both ways? I'm going to do it both ways. So I'm going to just do I'm just going to do the multiplying method first. So multiplying method, 4h times 3 is 12h over 9 times 2h is 18h. Oh, be careful. So h over h cancels and 1s go in their place. 12 over 18, what goes into 12 and 18? What times tables are 12 and 18 both in? They're both in the 6 times tables. 6 2s are 12. So what we're really doing is dividing numerator and denominator by 6, and our answer is 2/3. Now, I will 2/3, because you're dividing both the numerator and the denominator by 6. What you can do is put 12 ABC 18 into your calculator. You listening? 12 ABC 18 equals, you can't put the h's in your calculator. Ladies, I've cancelled the h's first, right? And then 12 over 18 has to be simplified. H over h, just remembering that any pronumeral like x or y or h represent a number. So this means 12 times h over 18 times h. If you had 5 over 5, you would put 1. H over h, that's something divided by itself. H just stands for a number. And though the numbers that h stands for have to be the same, otherwise it'd be a different letter. So anything divided by itself is 1. All right, let's keep looking. So what have we got in the next one? Can I try and cancel here, ladies? I want to cancel before the question starts. I'll do it, like down here, I'll just do what we were doing. Let's just multiply for a minute. What do you get if you just multiply? Anyone? What? You get 15dh over 6d. So if you just multiply, you get 15dh, because it's 3h times 5d is 15dh, over d times 6 is 6d. It's just, girls, you always put the numbers first and then alphabetical order. Now, what can cancel here? Anyone? What's 15 over 6? And I don't want a mixed numeral. What number goes into both 15 and 6? 3. So what's 15 divided by 3, 5. 6 divided by 3 is 2. Now, you have a calculator. All you do is go 15, A, B, C, 6. However, the problem is you'll get a mixed number and you have to change it to go back to improper. What happens to the D's, ladies? They cancel because that's 15 times D times H, 6 times D, so the D's cancel. Where does the H go? On the numerator. Now, I'm going to show you the cancelling method. Let's look. 3 and 6. I know 3 goes into 6. But 3 goes into 3 once, 3 goes into 6 twice. I'm doing the cancelling method. And a D from the numerator cancels with a D from the denominator. You are only ever allowed, so D goes into D once, D goes into D once. You're only ever allowed to cancel if there's a multiplication symbol. Nothing else. No divide, no plus, no minus, nothing. Everything's got to be times, otherwise don't even think about it. So what am I left with on the numerator? 5H. It is a bit tricky this way because you can't even see what's left. Over 2. The only thing is if you're going to cancel, make sure that your numbers are big and that you've done it clearly. Otherwise, it might be easier for you just to multiply and use your calculator. All right? Yes. You know what? I think if I start cancelling, it's going to get very, very messy. I'm not going to cancel. I'm just going to multiply the numerators, multiply the denominators. What have we got? 8 DH over 80H. Girls, I think it's easier not to cancel. Ladies, what cancels here? The H's definitely cancel, but what's 8 over 80? You divide them, you can put it on your calculator, 8 ABC 80 equals, but you divide them both by 8 and you get 1/10. So we get 1 over 10 and there's a D on top, so it's just D over 10. Are we okay with that? D times 4. 7 times 4 is 28 and throw on a D. What have we got next? 3 times 10 is 30 DH or HD, it doesn't matter. Now, we know the D's cancel because there are multiplication symbols between everything. 28 over 30, ladies, they're both even numbers. They're both divided by 2. So, you can do 28 ABC 30 equals, and you will get 14 over 15. Where do I put the H? On the denominator. Good. Next. Right, we're up to division. We ready? Dividing fractions. Keep the first one the same, change the divide to a times and flip the second fraction. What do I write? 2 over x. So, multiplying the numerators, we get 4x over 5x. What cancels? The x's cancel and we're left with 4/5. So the only difference with dividing is we change the divide to a times and we flip the second thing after it. Not the first thing, the second one. And don't flip both. So it's keep, change the divide to a times, and flip the second fraction. Look. Okay, what have we got? 10y over 20y. The y's cancel, and 10 over 20 is a half. Next one, x squared over 9, change the divide to a times and flip the second fraction. So it's x squared over 9 times 6 over x. 8y, change the divide to a times and flip. Oh yes, we have to come back and solve this. So what have we got? 6x squared over 9x. Now, we need to do some cancelling and treat each thing separately. 6 over 9, what's that? 2/3. We're dividing numerator and denominator both by 3. And x squared over x is x on the numerator. All right, the next one, we've got 2xy over 56y. We know that the y's cancel. Here, this x squared, think of it as an x times an x, and one of the x's on the numerator cancels with one of them on the denominator. If you want, I can write it like that, and one of those cancels with one of these. Even just put it as xx, and it's 2x over 3. So just showing that 6x squared is like x times x. Okay, what have we got here? 2x over 56. The y's cancel. Well, they're both even. So 2 over 56 is 1 over 28. So it's x over 28. These last two, 3x over y times 5 over 4x. If you can just do them on your own and then just check when they're done. Okay? And the x's cancel, and we're just left with 15 over 4y because the x's cancel. And the last one, 4y squared over 11x times 3x squared over 20y. We've got 12x squared y squared over 20 times 11 is 220xy. So one of the x's and one of the y's cancel. We're left with xy on the numerator. 12 over 220, they're both even. So can you just put that in on your calculator, that one? 12 over 220? And we get 3 over 55. Better to do it on your calculator for 12 over 220, because if you put 6 over 110, you've got to halve it again.